Welcome everybody. I'm your warm-up act until we fill the room. My name is Richard Worsfold, and I'm a Director of Business Development at OCE. And for those of you who have been around for the 2 days, this is part of a series of talking events that we have arranged in the clean tech zone, which are water, energy, mining, forestry, all hooked back into a presentation we did yesterday called Prospering in the Geoeconomy. And the point that we've been trying to make is that you may work in mining, or you may work in forestry, or you may be working in security, but if that's all you think, then you're working in silos. And what we're doing is breaking the silos and trying to show you that you can connect the dots across all the applications and do things with your technology. So what we have in this session today, in effect, can be testimonials. We have companies here that are going to tell you why where matters to their company. And our moderator today is Bob Ryerson, and if you'll all stand up and look at the piece of paper that you sat on, that's Bob's book. And it was actually the inspiration for what we have done here at Discovery. So with that, I will introduce you to Bob Ryerson and let him take over.
Thank you. Before I make my opening remarks, I'd like to introduce our panel. To my immediate right is Ravi Sithapathy, and Ravi is the Manager of Systems Innovation and Advanced Grid Development at Hydro One Networks, and he leads R&D and smart grid architecture, and is a leader in the development of global R&D partnership network for Hydro One. Ravi is well recognized also in the area of Canada-India relations, and co-chaired the Canada-India Science and Technology Mapping Report with David Johnson, who was president at the time, I believe, of that little university down the road from which I have my doctorate. Thank you for being here, Ravi. Next panelist is Dr. Ernest Arion, and he says call him Ernie, president of Winehawk Labs, and he has been involved in intelligent vehicle research and development and has a booth just around the corner here. Developing remote sensing platforms for many years, and has worked on remote climate data stations, GPS, positioning, and all kinds of other things in that area of location. And the focus in all of his work is enabling the best possible data collection, providing as much intelligence in the platform as possible. So, welcome, Ernie. Next to Ernie is Marnie McVicker, VP of Operations of Arion Labs. She has over 25 years experience in various roles managing the design and delivery of very complex systems, one of which is on display, and it's not flying, but it could fly, I understand. But anyway, in her role as VP, Marnie is responsible for moving new designs from engineering to production, in addition to leading a team that, as she says, likes to exceed customer expectations with every system they deliver. Welcome, Marnie. Next is Adam Greif, and Adam is the commercialization manager at ClearPath Robotics. Adam has a Bachelor's of Management and Organizational Studies from Western and a Master of Business Entrepreneurship and Technology from the University of Waterloo. Of course, that's a fine school, as I already mentioned. Prior to joining ClearPath, Adam worked for 3 years in business development at Salesforce.com, one of the world's fastest growing technology companies. And he is also a recipient of OCE's first job program. Welcome, Adam. Last but not least, sitting next to Adam, we have Remy Godin. Remy is a senior district engineer at Waste Management of Canada Corporation. And for the past 10 years with Waste Management, Remy has worked as a landfill engineer and gas operations manager for Eastern Canada. Remy has significant experience in the areas of landfill design and operation, compliance management, and landfill gas systems management, including energy generation for over 10 landfills in Ontario, Quebec, and the Maritimes. Thank you for being with us, Remy, and you will see this is a very broadly based group of people with all kinds of interesting experience that they will be sharing with you today. I'm going to begin with a few words about the geoeconomy, which we talked about yesterday. It's the new economy in which we find ourselves operating today, which has a different focus. It's being driven by and dependent upon geographic information. And that is, understanding location is fundamental to understanding how one succeeds in today's economy. And we have examples of, we have the book that we refer to here is being shown in our booth just outside the door here. As much as 80% of all government decisions involve geospatial information. I think that's an astounding number, but when you start thinking about that, you know, simple things like where do we put the road? Should we let them put the housing development here or over there? Where are we going to put the waste? Unemployment is at 9% in City X. What jobs are open there? And where are the people that might fill those jobs? What courses should we offer in which location? All kinds of interesting questions that are related to location. Furthermore, another estimate estimates that as much as 80% of all information in industrial databases is also tied to location. But what's really neat about today is we all have access to far more information, geospatial information, than we've ever had access to before. So it's changed the way we think, it's changed the way society functions. And it therefore stands to reason, with other factors being equal, those companies and agencies that effectively use geographic information will be far more efficient, far more successful in today's economy than those who don't. And these people will be showing exactly how that works in a range of very interesting and exciting areas, I believe. It also stands to reason that there will be a highly competitive marketplace for those offering tools and services that allow us to become more efficient using geographic information. So in summary, those who use geographic information, who understand it, who use it well, use it properly, will do well. And those who don't, well, they probably won't survive. It's the same thing as happened in Aboriginal societies. Those who understood where the water was, where the food was, they survived. Those who didn't. So I think with that kind of a background, I would like to now turn the floor over to first Ravi, and he will explain why where matters in his world. Ravi, thank you.
Thank you so much. Thank you so much. Yeah, you know, in the world of electricity systems, people think, you know, where would they ever care about why where matters? And that's simply because we operate a synchronous system. It's like a roadway where everybody drives at 100 or doesn't drive at all. And that's what it is, on or off. So from a synchronous perspective, everything is tied. And so there's a tendency to say, oh, it's more like the internet or a command and control, which is very centralized. And that's true. Partly it's true, but we derive a lot of our where, why, when, and what actually from the geospatial systems that we employ. And I thought I'd go through a couple of systems to be able to articulate that. So the first one that we have is about our system. We are completely interconnected across North America, and I've got 4 or 5 of them. To the bottom right, we have our network, our transmission lines that go across North America. To the left of the screen, we have the new thing called the phasor measurement. Ever since the blackout of 2003, we now actually have a system where we can tell in advance what's happening in different parts of North America and what its impact is likely to be. If only we knew that the tree limb that was touching a transmission line in 2003 that caused the outage in Ohio, and we saw the ramifications here, if only we knew the relay that misoperated in 1965 when the blackout occurred, and that time it was on our side of the border in Niagara Falls. If we only knew that, where it was coming from, we would have taken certain precautionary items. To the top left is where all our generation sources are, and then to the right, as you can see, is all about the weather map. You see, we are also subject to issues around thermal, heat, cool, everything that happens, lightning, storms, and so on. So while we may be centralized from a connectivity perspective, we are far more, in fact, in looking at what, where, when, and how it's occurring so that we can take actually precautions, so to speak. So I thought I'll just throw that slide up. That's, by the way, the Ontario Grid Control Center that we operate, and also the IESO's system at Clarkson. If you then take pieces of it and move on to systems protection, we operate in about 100 milliseconds maximum. With the inverters and static devices, we're going to move even lower, but we are about a 100 millisecond operations company. So when we detect things happening, we've got to take those corrective actions. We have to reroute power, much like the internet does, I guess, and we have to ensure that we have to restore power back after all that event has taken place. So the system protection and isolation is why, for us, why where matters. Because you can't take the whole system down when you got a problem down in one part of our network. So what do we employ there are largely, yes, current, voltage, frequency, sort of electric metric type sensors, but it is where that we look at. So there are parts of it, we have 250 stations, 1,000 DSs, distribution stations, and we need to know what's going on in them to be able to say, do I take off just one small portion, or do I take out a bigger ring, or do I take an even bigger ring? So what you're seeing here by way of the first to the left is the solar flare. I don't know how many of you paid attention. Every 11 years we get the solar flare. It has always been relatively in the north, and from 1987 we put several precautions. But there is actually a task force that says even as low down as Chicago, and in that line, actually solar flares are having its impact. And so we don't know what the climate change is going to do, but key is we have to keep the lights on. So there are task forces that deal with it. To the bottom right, you're seeing our typical protection systems. They actually discriminate between one and another. It may be 2 kilometers away, it may be 40 kilometers away, it may be 100 kilometers away. But we discriminate between where we should be isolating versus taking that whole section off. So if you imagine the Bruce by Milton line, we are now going to be taking the whole line out unless we really have to, otherwise the nuclear generation gets affected. So I just thought I'll throw up some slides on there. Yes, in the portion of systems protection and isolation, it's largely electric. But look to the bottom right on top, and that's lightning. And you will see that in the next slide when I talk of storm restorations and how we operate. Lightning is very, very important to us. And today, I don't know if you've been to the news items today, Telvent has got a product called Lightning. And what they will tell you is where the lightning activity is, what is it doing, what is the analytics relative to your network that you have or the business that you have, and what is the impact if you didn't pay attention. So that's the level that's coming. If you come to our control center, you'll see a weather map always onto the top left that tracks storms. We have emergency responses based on that actually come to a room called the war room, and we have fixed phones and everything and activities that we begin to enable. We mobilize our crews prior to certain major storms to the extent we can predict them so that our restorations are much faster. Tornadoes take place at least once a year in Ontario. We can't do much about them, but can we restore faster? And that's the sort of key here. If you then move on to our storm restorations and tracking and just sort of say, after the storm has passed, what do we do? 3 steps. One is we isolate what we cannot. We restore power through our alternative supplies that we can by automatic switching, and then the rest is a manual effort. So which truck do I send? What's the capability of the truck? Can it put this thing together? Can it do a pole replacement? All that is geospatial for us. And as the crew is doing its work, it needs to liven up the system. We can't call the control center all the time to say, can you switch, can you switch, can you switch? So now we are enabling what's called a mobile workforce from the truck to be able to light up the town, light up the village, and as it's being lit up, see the smart meter and see, is all the meters on? Simply because many times in the past, till the smart meter came, we would actually think everything is restored, the trucks will begin to go back, and then somebody will say, oh, behind that hill there, there's still a house gone. And so we need to go back and track that. So now with the smart meter, we can ping every smart meter, and it'll tell geospatially what is happening to it on the electrical side. So the restoration efforts that we go through will be much, much better enabled, even as we enhance the geospatial aspects of it. I think the next one is about our advanced distribution system called the Smart Grid Project in Owen Sound, a flagship project that we are putting everything together. And in this experiment, what we are looking to say is how much of geospatial and electrical sensing and people mobility can I integrate for better operations, management, and efficiency of the network. In other words, in the past, we had a single response, and that was a system planning criteria. It was a textbook style. We built it, we operated to that. Today, with all the cost of sensors coming down, the telecommunications coming down, and geospatial information being available, we now want to see, can we actually raise the headroom without having to raise the investment? And I think there's a lot of latitude that as you take all this into account, you'll be able to better manage. You don't need to constantly keep rebuilding or expanding your capacity, but better utilization of capacity will take place. So I just thought I'll throw, some of them are around here, by the way, the stuff that we are talking about. And I think with that, I just want to wrap up to say, nobody thought in the electrical system that we do, why, where matters. But I can tell you, I never thought of it that way till they asked me to speak. But that's in our guts here. Why, where matters is important. And when and what is also equally important to us because of the 100 millisecond operation cycle. So with that, Mr. Chair, thank you very much.
We'll save time for questions at the end, and I'll ask Ernie.
All right, thanks, Bob. Hi, everyone. I'm going to talk a little bit about what we do, but what we do always comes down to data. That's the most important thing in everything we do. And so if I can be so bold as to riff on Pirelli Tires advertising slogans, data really is nothing without a reference. Just to give you a bit of an intro into who we are and what we do, we're dedicated to enabling the collection of high quality, relevant, useful data. And that's most of everything that we're focused on. And the way we do that is through technology that is primarily designed to be incredibly easy to use, reliable, and repeatable. So we've got highly intelligent systems that require very little input from users, and they're incredibly robust and reliable. And part of that is not relying on a human operator in the field. So, if you come to our booth, you'll see a couple planes there, but we don't consider ourselves a UAV company. We consider ourselves an intelligent remote sensing company. And there's a very big difference there. It just so happens that our remote sensing tool is a highly intelligent aerial platform. But when it comes down to it, our partners, our customers, they don't care about the platform. What they care about is the quality and the timeliness and the utility of the data that they're getting. So what we're talking about are civilian users who want data, they want reliable data, and they want to avoid having UAV operators on staff at all times. If we're talking about a utility, if we're talking about a farmer, the last thing they want to do is to have to train a UAV operator to take part in their normal day-to-day operations. It just doesn't make sense for them. So what we're talking about is actionable information for those partners that we work with. Now, in that, it really very quickly comes back to where. Because when we're talking about the data that we're getting, if we're getting 2 millimeter resolution over a farm field, we can identify leaf by leaf basis. But if you don't know which leaf you're talking about, then you don't know where to change your inputs, you don't know where to take mitigating action for pathogens that are spreading across the field. It really matters where that leaf is, no matter how good the resolution is in the image of that leaf. Sorry, and of course, when you're talking about linear infrastructure and things like that, it's not enough to know the road is bad. We all know the road is bad very, very quickly. The field operators know that. But nobody has infinite resources. Nobody can go out and say, I'm going to fix every single road in my jurisdiction this year because resources are limited. You have to be able to say, I'm going to fix that section of the road first. So the question comes to getting quality data, relevant data, to the people who are making the decisions at the decision-making time. And so that really comes back to the amount of information and how it's useful. So our niche is really focusing on information. Information that's useful, that's timely, efficient. We can go out there, we can get it quickly. We're talking about sensors that are coming online now that really weren't available that long ago. And a 200-gram LiDAR system is one of the things that we're flying. And you talk to people who've been flying LiDAR, and that's a pretty impressive sensor. And very localized, because we don't need infrastructure. We can go wherever the data needs to be collected. But it really always comes back to people who need quality data. So in all of this, and this is very quickly going to tie back into the question of where and why that's important, is highly usable systems that require very little training to use. The data has to be handled intelligently. The operations have to be handled intelligently. Mission level stuff has to be handled intelligently. Things like survey location, the parameters, the flight control, the survey specifics itself, takeoff and landing, all of these things have to be handled by the aircraft itself. And you really can't know what to do next until you know where you are now. And I say where you are now because time is just as important as position in a lot of this stuff. And again, everybody knows Google Earth. It's a wonderful, wonderful tool. Google Maps, great. You can see satellite data. But is that useful for a land use planner? Well, maybe it is, but probably not, because they want to know, has a farmer just put a road across that field? That's important because it changes how they talk about the developments that are going in after there. They need to know what's happening now. So in all of our work, we're talking about fly and forget. You toss the aircraft, it takes off, it does its job, and it comes back to you when it's done. And then you go and you pull the data off. That requires a great deal of information as to where, when, what the conditions are happening now. And it's really important, even from the quality of the data perspective, or the usefulness. This image there, are these good conditions or bad conditions? Well, it really depends on who you're talking to and what they're interested in. In this particular case, it's grassland over an ecological preserve, in early spring. That's what it's supposed to look like. If you're talking about a hayfield, in the middle of August, that's really not what that's supposed to look like. And you get people who'd be very upset about that. I can just give you a quick example of why this is so important, surveying rail infrastructure. Now that's a great high-resolution picture of an infrastructure element. Now that's wonderful. You got great detail, but when resources are being allocated for repair and things like that, that's not enough information. So now this is better. You've got a little bit of context, so you can see it a little bit better. It's adjacent to a rail line. It's slightly clogged up. These are all good things, but it's still not enough to be able to take a decision on what you're going to do with that. So now, okay, you can see it's part of a long line. There's industrial sites on the side that impacts what's actually coming through that culvert. This is all better, but it's still not enough for a decision maker at some time looking back on this data or comparing it to data they had last year. So it's only when you can add in where exactly was this taken, what were the conditions taking around it, how confident are you in this data, when was it taken, and being able to reliably reproduce this so that you can go back in a time series and say, okay, this thing has been flooding every single spring, but it only floods for a couple weeks and then it's gone. It's not a big threat. We'll go and fix the other one instead. So in our case, the process of operations, really you turn it on, you throw it, it flies, it does its job, it comes back to you, you take it home, and then the data is on the onboard network. That takes a lot of thinking on the part of the aircraft to be able to do that, and that coupled with the fact that there's no programming required in the field, and that the launch and recovery is a very short area required. You don't really need anything if you can stand on the back of a pickup truck and do it. It really comes back to the fact that ease of use for our customers, for our partners. If you can fly a paper airplane, you can fly our system, but what that requires, of course, is knowing where you are, what you're doing. The system has to know all this information to be able to take the appropriate action. And it all comes back to a reference. Any information you get isn't really useful unless you can reference it to something else. It has to be referenced so you can find it again, so you can make decisions based on it, so you know what action to take about it. Basically, it all comes back to where are you and where is that tree or pole or culvert or whatever it is that you're looking at. You can't do anything with data. It might look pretty, but you can't do anything with it unless you know exactly where it is, when it was taken, and what you're looking at. So thank you. If you have any other questions, I'm just across the way there, and I'd love to talk to you. Thanks a lot.
Thank you, Ernie. The threats I used to ask the speakers to stay on time have absolutely worked wonderfully well. Thank you very much. Marnie, thank you.
Hi, my name's Marnie McVicker, and I'm from Arion Labs. So who or what is Arion Labs? We were founded 5 years ago with a lot of help from OC and Discovery. Give Richard some props here. And we are a market-defining micro-UAVs company. So why? So I'll have a little look and see. That's what we look like. It's hard to tell from that, but that's about a 2-pound system. It flies in winds of excess of 50 kilometers an hour and gusts of over 80. And a lot of that comes down to because we know where we are. So it's designed so that anyone can fly it. Well, how can anyone fly it? Well, the system actually flies itself and you just tell it where it needs to go. And that's based on knowing where you are, where it is, and where you want it to go. Very simple. All the autonomous stuff that's there requires knowing where things are. So now that I've done the marketing stuff, I'm going to go on to how our customers use where to do their job, because what they do is way cooler than what we do. So in the case of a missing person, the police can go up and fly, and because we know where the system is, where the camera is focused, if they see something out there, they can actually get that location from the system and send the right people to the right location. Wildlife monitoring. Oh, this is very cool. University of Alaska went up and flew off the Aleutian Islands this winter in order to count sea lions. They took off from a boat and landed on the boat, even though the boat moved. And that was because the system knew where the boat moved to and where it was. They actually went out there, and not only could they count the sea lions, they apparently can tell which gender they are. I don't ask how. Volumetrics, this is really cool. This is one of our earlier customers. What they do is they fly what we call an auto grid. So they go up and they say, I want to cover an area so big, I want so much overlap for my cameras, for my pictures. Everything is geotagged. They bring that information back, and they have magic software, and they're really smart people. They stitch all that together based on the geotag information, and they can do volumetrics. They are to the point now where they are within 0.05 error, percentage error. Unheard of with an airplane. They do it in about 45 minutes. Again, because all the imagery is geotagged. This is pretty cool. This year, Nome, Alaska missed its final fuel delivery. The truck couldn't get in, there was a storm. So the US government decided that instead of letting Nome run out of fuel in, say, March and freezing, that they would have a Coast Guard cutter take in a Russian oil tanker to a frozen harbor. There's a lot of nervousness up there because they're going through ice that's 20, 40 feet thick, and they were very nervous. How are they going to know where to bring this system in? So they borrowed the Scout that a local oil company had up there. They went out and again grabbed grabbed images, all geotagged, brought it back, and we were able to do a 3D reconstruction for them so they knew where the ice was weakest, where it was strongest, so they could bring the ship in through the weakest part and then lay the fuel lines over the strongest parts. It was very cool. We were all very excited about this. This has nothing to do with it. There's just a really cool picture of the ship coming through the ice. Again, taking the imagery that we can create with the geotags, you can put together a 3D model of a facility. So if you're doing infrastructure inspection, surveying, you can go out and actually look and see what's there. Infrastructure, very big, very important. A little less on the 3D side of things, but what you need to be able to do is if you're going to fly this up, let's take hydro for an example, and you want to do an inspection, you need to know where the problem is, be able to relay that information back to your ground crew so they go to the correct location. Oh, this one's pretty cool. This is new for us. So what our customer does is they have 2 cameras. They have a daylight and a near IR, and they go up and again do an auto grid, and they cover the same area with both cameras. They come back and merge that data, and again through their magic software, they can go and determine where there's vegetation, where they need to go look at the areas where they need to do more work. Again, because they know where the information is coming from. Beyond line of sight, there's pretty cool stuff. So what our system allows you to do, because you know where it is. You may not be able to see it, but you can see on the map exactly where your system is. You can fly, say in this case, on the other side of this train. This happened in Hamilton not that long ago. They were able to use a system, stand at a safe distance to go and see what was on the other side. So I had one more, but I guess I must have flipped past it. The other thing that's important for us is our system's very small. And it's really hard to explain to people how small is. But if you take your fingers and you hold them about 1 centimeter apart and you hold them out at your arm's length, that's how big the system is at 200 meters away from you. And I know from personal experience, if you take your eye off of it, it's gone. You're never going to find it again. But if you take, it knows where it is, it knows where you are, and it can show you on the map where it is so you don't lose it. So you, in theory, don't smash into trees or buildings or other things that when you take your eye off of it, you tend to forget and hit. So if there's any questions, please stop by the booth. I'd be happy to answer them for you. Thanks.
Martin, I didn't mean to scare you off the podium too soon, but Adam, please.
Thanks. Hi, everybody. I'm Adam Greif, and I'm the commercialization manager for ClearPath Robotics. And I'm here to talk to you today about why where matters for robots, and very specifically, robots that work outside field robotics. And before I get started, I just want a quick show of hands. Who in this room knows where they are right now? It's not a trick question. I can tell you if you don't know. And I think the point of that question is just, this is something that we take for granted as people, and it's something that we need to transfer into technology. And I'm going to go through this presentation and tell you why where is the most critical question when it comes to outdoor automation. And before I do that, I'm just going to start with a quick overview of the company. Or I'll just stay on this slide. Oh, sorry, I have to do it. That makes more sense. So ClearPath Robotics is a spin-off of the University of Waterloo. We're still based in Kitchener, 100% Canadian owned and operated. We specialize in the development of robust and reliable unmanned vehicles, like many of my colleagues here today. We currently, well, this is a little bit out of date. When I sent in this presentation, we had 15 employees. We've now grown to 20. And we're not just servicing Canada and the US, we're also servicing countries in Europe, as well as Asia, Australia, really throughout the world. And of course, we've been given tremendous support by various Canadian organizations, OCE being one of the most prominent. We were recipients of the Embedded Executive Fund, as well as first job funding for myself and market readiness funding to help us commercialize some unmanned vehicles for environmental monitoring, and specifically water monitoring. These are a couple of pictures of two of our core products. That's the Husky unmanned ground vehicle on the left, and, well, sorry, on the right, and the Kingfisher unmanned surface vessel on the left. And as we go through this presentation, I'm going to explain how these products are being used in various industries, ranging from military to space to mining and agriculture, utilities, to talk about why where is so critical when using robotics in the field. And this is a list of some of our customers. It's both to put an exclamation mark on ClearPath's success in its very short history, as well as to highlight that we are very plugged into the development of robotics. These are all top-tier technical institutions throughout North America and the world, and they've given us tremendous insight into how robotics are being developed and used globally. So these are two of the most common applications for field automation. The first is space, and the second is military. In space, it's absolutely critical to design new technologies that can articulate where your technology is, because there's no humans in space to gather that information for you. Right? Again, we take for granted that we know where we are at all times using sight, sound, touch. The robotics needs that technology developed in order to articulate that information. And when you're in space, you need to know exactly where you're surveying, because it may be critical for landing a manned mission at some point. And you need to make sure that your astronauts are safe. In the military, knowing where you are is going to be critical for surveillance missions. You don't want to put a soldier into a hazardous environment if you think that in any way they may be harmed. To take that one step further, it's also important to deploy weaponry on robotics or detect weaponry on robotics, such as landmines, and you want to make sure that you're not miscalculating that by a centimeter. Precision becomes paramount when you're talking about field robotics. A few more industries where robotics is being adopted, and we're seeing this across the board from all of those customers that I just had on that slide, is in mining. Again, that's primarily for surveillance, but it's also for locating important minerals like gold and ore and things of that nature, right? So being able to find where that is a matter of millions of dollars to these organizations. It's very quantifiable, tangible results. And where is the critical question that they're trying to answer by use of robotics? In agriculture, as you saw from my colleague in aerial surveying, you want to be able to detect an insect on a leaf. You want to be able to detect a disease on a leaf to make sure that it doesn't spread. Where is critical in agriculture? In energy, you're monitoring various wiring, you're monitoring the power grid, again, as one of my colleagues here articulated already. And it's very important to know exactly where any power disruptions may be. This could affect an entire city, it could affect an entire industry. Hospitals may be affected, and people can get hurt. Where is absolutely critical. And of course, in environment and oil and gas, these are two areas where we play heavily. Our unmanned surface vessel, which OCE has done a fantastic job in supporting, has a built-in GPS where you just launch it on a tablet, a touchscreen. You determine the path that you would like it to take. It collects the information from the water that it's profiling and transmit that back to you in real time. And it profiles exactly within centimeters of where it is, because you need to know, is there a sinkhole in this exact location? Where is the water moving this quickly? Can we put a boat here? Is that safe for people? Right? And that's what robotics is really used for across the board. And then in oil and gas, we're seeing applications such as oil pipe inspections and things of that nature. Be able to find that leak before it happens, or while it's happening, and identifying that quickly and getting a response team there is absolutely important for saving millions of dollars, saving the environment, and saving hazards from surrounding residential areas. And if you haven't made the connection yet, many of these industries are extremely critical to Canada and the Canadian economy. And just as an interesting point that I want to put up before I get off, many of these industries are critical for our exports and for the Canadian GDP. And enabling robotics to make these industries more efficient is going to keep Canada competitive on a global stage. And again, in order to do that, where matters. So if my point hasn't been lost, I just want to say that where is critical to robotics. Robotics is critical to Canada, and that circles back again to localization technology, whether it be GPS, whether it be LiDAR positioning. It's giving our automation technology eyes and ears to know where they are and be able to get that information to us. So thank you very much for listening.
Next, I'd like to call on Remy Godin, next and last. Thank you.
Hi, my name is Remy Godin. I'm the Senior District Engineer for Waste Management of Canada Corporation. I'll give you a bit of an introduction on waste management. We have about 43,000 employees. It's a $13 billion company. We're the biggest waste management service provider in North America. And where matters a lot to us, because as you will see, the service that we provide is we're basically a big transportation business, and also we also have to manage the airspace at our landfill sites. So today, for us, GIS and GPS is used in different applications that can be in landfills. Basically, if we start with landfills, the main service that we provide is airspace. So we sell airspace to municipalities, businesses. And we need to optimize that airspace because we operate under permits from the Ministry of the Environment. And so we have a defined volume to fill. And it's really critical for us to optimize that volume with the best compaction that we can achieve. And also to stay in compliance with our permits, it's always critical to know where we are in that box to make sure that we don't go outside our contours. And also I'll cover a portion with our collection business where we use a lot of mapping, GIS, and the GPS to know where our trucks are and also how to optimize our routes, our collection routes. So I'll start with the landfill. So basically, there's a system that we basically did some studies on, that where you use a GPS sensor on the landfill compactor and also on the bulldozers to optimize compaction. Those systems are fairly expensive, so we decided to undergo some pilot studies and to complete financial analysis on those systems. So for us, what's really critical, the key factors were the amortization rate. So for us, the way we work with our landfill facilities is that we deplete the facility based on volume, because that's what we sell. So basically, your net book value, all your expansion costs and construction capital costs are going into that amortization rate. So you can understand that the higher the net book value of a site, the more precious is the airspace. So those are the sites that we want to work on. And also the sites for us also a benefit is surveying costs, because by having that piece of equipment on the bulldozer or on the compactor for us, it saves us from having a surveyor on site to put some stakes and take some shots. And it's also a safety issue for us because we have pretty big equipment. Soft benefits for us is basically leachate reduction. Leachate, for maybe just landfill 101, leachate is when rainwater mixes with the waste, that becomes leachate. We need to manage the leachate. So by having proper profiling on the landfill, on the cap, it minimizes the volume of leachate generated. So by having GPS equipment on our bulldozers and compactors, the operators can really have a proper profile to make sure that surface water is shed away before it has a chance to infiltrate into the waste mass and become leachate. We also need to be careful, as I say, as per our permit, we are basically given a box to fill, and we cannot go outside the contours of that box. So by having equipment on the bulldozers, we can make sure that we have proper shaping of our slopes. On the other side, to underfill avoidance, because quite a few of our landfills, we need to install synthetic caps. So there are no chances for us to go back and reclaim lost airspace due to underfilling after installing the cap. So that's why it's critical for us to really go to contours. Cover reduction. At the end of each day of operation, we need to cover the waste mass with a minimum of 6 inches of cover. And it's critical for us to minimize that volume, because depending on sites, some sites it's a revenue generating cover, but some sites it's just imported material that is an expense to us by having to import material and also by a loss of airspace. Gas well systems. All of our sites have landfill gas collection systems, because as the waste mass decomposes, it generates landfill gas. So we have a gas extraction system which consists of vertical wells. So those are basically piping system that is installed inside the waste mass. And there are sections sticking out of the ground which are the wellheads. And those are pieces that we have to be careful that the operator don't damage. So by having those marked into the mapping and GPS system, it prevents any damages. And you can see other advantages. We have to build roads. So GPS is commonly used now for highway construction. Our sites are just the same. We need to build perimeter roads, access ramps on our sites. So that saves us a lot on surveying. Ditches work and so on. So here you can see a landfill compactor. This is a 60-ton landfill compactor. You can see on top of it, you can see the antenna with the receiver. We have strict procedures on how we place waste to optimize compaction again. So the way it needs to be done is, as the truck unloads, you see a bulldozer and a compactor, the waste needs to be placed in the 1 foot thickness to optimize compaction, and they need to be followed by 4 passes of compactor. So you'll see with the system we have, it basically shows the operator where he is as far as his grade, so how much more of a fill he can go to final contour, and also we can set it up if you put it 1 foot thickness or 3 foot thickness, and also for the number of passes. So we have a display that will show, okay, you have achieved, you'll have like a red square if you have not done no passes, and when you achieve 4 passes, it turns to a green. So the operator knows. The operator knows that he's been over the waste, because if you don't follow up proper pattern, you can get lost in a way. So this is the receiver, quite common. And we decided to go with Carlson. Same thing, we have a procurement team that basically did an assessment for a service provider. So we went with Carlson, so you can see the receiver and the processor. And this is a display. So here on this display, this is inside the cab of the bulldozer or the compactor. On the left side, you can see that what we call the working face, so where the waste has been placed. It's a bit hard to see, but this gives him the elevation at where he stands. You can see in this case, he has a fill of 7.34 feet to get to final contour, so you know it's not over contour. Can also be set up for his lift thickness. And you can see the squares. So on the edges, you can see red squares, so he's not done with his compaction. And the centerpiece is all green, meaning that he's achieved at least 4 passes to make sure that everything is well compacted. And this is a system that the operators really like. At first, there's always they don't really feel that they need it, but after using it for a while, they realize that it's a time saver. On the collection side, we have thousands of trucks on the road, so we're a big collection company. So when we bid contracts, it's really critical that we use mapping software and GIS to optimize our collection routes, because the less time it takes us to collect the organic waste, the recyclables, and the garbage, the lower rate we can offer to municipality or business. So the system we use is WebTech. It's basically it's a fleet system, so there are receivers inside all of our trucks. It's using GPS. All information is transmitted via cellular network, goes into a server, and then you can go to our dispatch and call centers. Because depending, like in the morning, what happens is the truck operator gets in his truck and he already knows his route, so he knows he needs to go on your street, pick up your different types of waste, and at the end of the day, we can save time. And that's also saving us time, where if it really goes well, we can assign more routes on one driver. So there's communication between dispatch and the collection truck. So those are basically the key thing for us. Is what we knew is we can establish geofence, so we know when the trucks get out of the yard. And also we have reports such as idling. We want to minimize idling. We want to make sure that our guys are not stopped at the Tim Horton for too long. So that's something we can monitor, because sometimes the guys will go fast and take a break for some time. So now they know, okay, you've been parked at Tim Horton for half an hour, move on. We also manage speed. So we know how the average speed that a truck has been going. We can install sensors on our trucks even. You can know how much gas is left and so on. So quite a few systems, and more hauling companies are all installing those systems on their truck now. For us, the critical thing is to know where our trucks are, especially for a roll-off truck, for instance, for business. It gets a call. If he's in the area, you can easily move on and collect your bin that way. So we can run multitude of reports. So as I say, idling, speeding. What for us is also the distance traveled, and idling. So benefits for us is greater efficiency for fleet, because we have route managers. The typical hauling division will have about 25 trucks. That's pretty much average size in Ontario. And we have route managers, I say, to make sure that we manage our fleet properly. So with these systems, on top of the route managers that are spending time on the road, the dispatch and even the route managers can easily run reports even from their trucks with cellular internet to know where the guys are and how things are going, if there's a truck that's stuck, whatever. And also the key thing for us is idling, and basically know where our trucks are. And green benefits, also the key thing. Those are kind of the key thing for green benefits. So we control the speeds on our truck to make sure that there's no speeding, so to control the air emissions. Idling, we know if a truck has been parked idling for too long, so we can run reports for that. We can also analyze the driving performance of a driver, so sharp acceleration, strong braking. Those are all things that we can monitor. We have sensors in our trucks too for maintenance, so we can do for services. And overall, we can run reports and basically integrate everything in one system for the whole company. So basically, we can easily run a report from a hauling division in California versus a hauling division in Ontario. And also on landfill compaction, we've been doing some studies at multitude of our landfills, and with OC, we've been doing some work at our Saint-Sophie landfill north of Montreal. So as I say, we run different pilots on different size of landfills to see what's really the size where this is cost effective. Thank you.
I didn't realize until today that Waste Management Corporation and Hydro One are actually geospatial companies, but I think it's fascinating to see the range of application and the range of impact of wear in all of these companies that are represented here in the front of the room. We'd like to open the floor for some questions. If anyone has any questions for the panelists. I have one question that may be of particular interest to the people that are involved with robotics. There's a recent technology developed at the York University and the Geodetic Survey of Canada, and it allows one to locate oneself when this is put into full commercialization within 2 centimeters anywhere in the world without any local GPS receivers. What impact do you see that as having on your business? I know that's that to Ernie and Marnie first, but I think it has implications for the others as well.
Okay, well, I guess from our perspective, anything that can improve our knowledge of where we are improves our ability to do the work that we need to do. Anything that can reduce the uncertainty in positioning, that can reduce the time required to get highly accurate fixes in terms of if you're stitching imagery together, the better you are in your initial guess, the better the stitch goes. All that stuff, everything just gets better, the better and the faster you know information. That's how we look at it.
Okay, and I'll add that this technology also makes it possible to do it instantaneously and gives you 1 to 2 centimeter horizontal and 2 to 4 centimeters vertical.
Yeah, again, just knowing where you are is key. The better the accuracy, the better the data you've got. In addition, we fly in locations where GPS is poor, and some of our users fly where there is no GPS. We don't talk about those guys so much. So that would be key to them. They don't probably need the accuracy that the other folks would need, but anything that, again, the better the quality information going into the software packages for doing the stitching, the better quality the information is coming out of that.
Yeah, from an environmental monitoring side of things, I can tell you that our boat is very often operated in deep brush areas where they're assessing flood risks, where you need to know both the horizontal and vertical positioning of the vehicle. And in those areas, GPS access is very limited because of the brush. So in areas like that, it's absolutely critical for our customers to have localization technology that doesn't involve GPS, and that can be accurate to within those 2 to 4 centimeters that you mentioned.
Okay. Yeah. Are there some other questions for the panelists? Obviously, we're clearly able to present the importance of wear, and I particularly appreciated the fact that everybody not only stayed on time, but allowed us a little bit of extra time at the end. Thank you very much for everyone and for the very interesting presentations. Thank you.
Thank you, Bob. And I urge you to visit Bob out there and take a look at his book. And most of these people are in the WOW zone or nearby. And I suggest if you have more private type questions or you want to go buy one of the systems and you don't want us to know you're going to buy it, they'll look after you. In closing, again, thank you, and I have a little gift of appreciation for each of our people here.